So hopefully you're feeling more confident with ionic equations. So here are some practice questions for you to have a go at. You can download the worksheet by following the link at the bottom of this page. So for these questions, 1 to 9, the first 4 have been completed but need to be balanced. And then 5 to 9, you need to complete the products and also balance them as well. For these questions, you've got to actually write the equation from scratch. So first of all, start with the balanced simple equation, and you've got magnesium with sulfuric acid, sodium carbonate solution with nitric acid, and copper oxide with hydrochloric acid. So key thing, get the formulae right, make sure you've got the right products, and then take it from there. Okay, so hopefully you managed to have a go at those, and now we're just going to go through the answers. So here are the answers to the first set of questions, where I've put in red where we've had to make adjustments. The difficult one is of course question 4, where you've got to make 4 adjustments into the equation, with your remembering to have your 3 Cl2 there, and your 6 hydroxides, 5 chlorides, and 3 waters. For the other equations, you've had to complete them as well. So copper 2 plus copper and hydroxides obviously gives you copper hydroxide as a solid. Question 6 is the reaction of a carbonate with acid, and zinc with acid to give you hydrogen. Question 8 is a straightforward redox reaction, and question 9 is neutralization. So hopefully you managed to get those okay. So for question 10, we need to first of all write the equation. So the equation is going to be magnesium reacting with sulfuric acid to give you magnesium sulfate as a solution and hydrogen gas. So we're going to break those down into ions, and we can break down the sulfuric acid and magnesium sulfate, which I have done there. As before, the magnesium sulfate has become Mg2 plus and SO4 2 minus, and sulfuric acid has become 2H plus and SO4 minus. Don't forget, because you've got H2, that then becomes 2H plus. So let's see what we can cancel down. If we repeat that equation there, and you will see that the sulfate ion is on both sides of the equation, so that can be discounted, and that looks like that's all we can discount. My final equation is going to be that. For this next equation, we've got to do sodium carbonate with nitric acid. That will of course produce sodium nitrate, water, and carbon dioxide gas, which we have there. Again, it's absolutely vital that the formulae are correct, otherwise the rest is going to go terribly wrong, and that we balance that correctly. So let's break that down into ions, which I've done there. So the sodium carbonate is going to become 2Na plus and CO3 2 minus. Nitric acid, like so, remembering the 2 means I've got 2H pluses and 2 nitrates. The same goes for sodium nitrate there to give me those ions, and the water and carbon dioxide I cannot break down. So we'll repeat that and I'll cancel. So what can I cancel? Well, I can cancel my sodium ions. So let's get rid of those. So sodium goes both sides of the equation. What else can I get rid of? Well, my nitrate ions as well can go, and I'm left with this equation here, which is the reaction of a carbonate with acid to produce carbon dioxide and water. Our final equation is going to be reaction of copper oxide with hydrochloric acid. So again, first of all, I have to write the equation, which gives me copper chloride solution and water. So let's break those into ions where I can. I can break into ions my hydrochloric acid, because that is a solution, and I can break up my copper chloride because that is a solution, and I forgot my 2 there. So once I've done that, I can of course start to cancel. Remembering I've got a 2 there. So what can I cancel? Well, I can cancel certainly my chloride ions there and there. Anything else doesn't like it because my copper becomes copper 2 plus, and the oxygen goes to become water. So I am left with this final equation of copper oxide reacting with acid to produce copper 2 plus and water. So I hope you found those examples useful. With all of these, it's just a matter of practice, but the key thing is anything that has aqueous after it can be broken down in its 2 component ions.